So we're looking at completing the square when our leading coefficient, which is the number that is multiplying our x squared, that's our leading coefficient, when the leading coefficient is not 1. So in this case, we have y equals 2x squared minus 4x plus 5. So we need to think about what we normally do when we complete the square. And if you're not quite sure on that, I have a different video you can take a look at. But when I complete the square, I'm actually physically making a square. I have an x squared, and then I put some number x's here and some x's here, and then I fill in how many go right there. So for this particular problem, when we have a leading coefficient that is not 1, we're going to make multiple squares. So I'm going to try following along with a picture as I go through and do this algebraically as well. So I have 2x squareds, which means I have an x squared there, and I have another x squared here. And if I have negative 4x's, and I'm going to build 2 squares, that means I need to take that, and I need to put 2 of them here, 2x's here, and 2x's here. So I'm going to divide that in half and put half of them with each. And the reason why, again, I'm dividing by half is because I have 2 x's, or 2x squareds. So algebraically, what this looks like is I would have my 2, and I'm factoring out a 2 from just these first 2 terms, not from the 5. So now you can see I have 2 sets of an x squared and 2 x's, 2 sets of those. My next step is to take these 2 x's, and I need to put them on one on each side. I can't put them both on one side because that would not make a square. If I put 2 of them here, that does not make a square. So I need to put one on each side. What this gives me now is I have an x and an x as a side length for the x squared, and now that's a negative 1 and a negative 1 because I have negative 2 x's on each. So I'm starting to make an x minus 1 square. 2 of them, as a matter of fact. Now, in order to complete the square, okay, to actually finish making these squares, I need to add some number of unit tiles right there. So for each of these squares, I need to add 1 because negative 1 times negative 1 is positive 1. So again, algebraically, my next step would be this. I have 2 sets of squares that are x squared minus 2x plus 1. So an x squared, 2 x's, and plus 1. That's where I get this. And I have 2 sets of them. That's why I have those right there. So if I just added 1 to both of them, so I added 1 twice, my equation is no longer balanced. So what I need to do now is subtract away however many I've added, which is 1, 2 times. And the 2 is from that number right there. The 1 is from that number right there. I still have this plus 5 on the outside. And now all I do is rewrite this. So equals 2. This is now my square. So if I would factor that, I'm going to get an x minus 1 square. And you can see the side lengths are right there, x minus 1, x minus 1. So I have 2 x minus 1 squareds. This makes negative 2, and negative 2 plus 5, I'm going to combine like terms to get plus 3. I now have it written in graphing form. My vertex is going to be positive 1, positive 3. It has a stretch factor of 2. So if I want to make a quick sketch of that, it would have a vertex at 1, 3, and have a stretch factor of 2. And there's my graph. Hope it helped.